Hi, everybody. Welcome to VMware Code Session 2773, VEBA Revolutions, Unleashing the Power of Event-Driven Automation. Hi, my name is William Lam. I'm a Senior Staff Solutions Architect working out of our VMware Cloud Service, which is part of our Cloud Infrastructure Business Group at VMware.
Hey, and I'm Michael Gasch, based out of Germany, working for VMware and Office of the CTO as a staff engineer.
Okay, so here's a look at our agenda. We're going to do a quick introduction into what is VEBA if you've never heard about it before. And then we're going to jump straight right in and take a look at VEBA in action, going from source all the way to a function deployment in under 10 minutes. Then Michael's going to take you through some of the net new features that we're introducing in our upcoming release of v0.0.7, as well as cover some of the project features and hopefully get into some interactive discussions with you around some of the features that you might be looking into. And then we'll close the session with some call to action, and obviously we'll have some room for some Q&A. So what is the VMware Event Broker Appliance? Well, this is a project that Michael and I started back in 2019 as an open source project. We had a really simple idea. Could we take some of the modern technologies and innovations that's been coming out of the cloud native world, like Kubernetes as an example, and take that and augment that and help our cloud admins build easily event-driven automation based on vCenter server events, right? Concept is pretty simple. Today, vCenter server ships with over 1,800 plus events. These things come in the form of state changes in the system, for example, like a virtual machine getting created, a host getting added, VM getting deleted, but also other things like alarms, which is a very specific type of an event, which are more metric-based, right? A certain amount of CPU gets utilized, a data store filling up. And this information can be used to derive some really basic event-driven automation. And that has really been in the product for probably over the past decade. Examples like sending an email, sending an SMP trap, or running a command on the vCenter server appliance. Now, these event-driven actions haven't really been modernized to any certain degree, but times have changed. Customers want to be able to take these events and do something interesting with it, especially some of the use cases that we've seen from our customers. And so Michael and I embarked on this journey, creating this fling in hopes to hear and understand from our customers, what they think of this particular solution, and is this something that really resonates with them? And to our surprise, this was something that really resonated with customers. And in fact, many, many use cases still exist in today's time. So speaking of use cases, what are some of the ones that we see? The most popular one are notifications, right? When something happens, I want to get alerted. For example, a VM gets deleted, or maybe I get a failed login from vCenter server. I want to get this maybe using something like Slack, Microsoft Teams, even maybe a text message, right? Really basic, but we certainly see this as one of the most popular use cases. Going beyond the basic notification, customer starts to think about, okay, what can I do with VEBA from an automation standpoint, right? I look at my automated workflows today, VM gets provisioned, I need to go update a CMDB. Generally, that's manual, right? What if we can automate that aspect of it? Reconfiguring a VM, so a VM gets created, I want to automatically take a look at its host name and apply various vSphere tags to help me identify who's the application owner or system owner. We also see a lot of tasks where we're actually doing automation to external systems, right? Not just vSphere, but other components within the infrastructure. Beyond that, we see a lot of integration use cases, right? Internal use cases, if you have internal services that's running within your IT firewall, but also externally to the public cloud, integrating with things like AWS, for example. We see this a lot with VMware Cloud and AWS customers, or even Azure VMware Solution customers, where they're integrating with some of these public cloud services, right? For example, consuming S3, maybe AI services, right? Makes it really easy as long as it has an API endpoint. Taking another step further, SREs for remediation is quite popular, right? None of us like to wake up in the middle of the night, and I'm sure we've all had that experience for the first time, right? A host goes down. We know that hardware fails. We don't want to get woke up in the middle of the night. vSphere HA will automatically take care of VMs that get restarted. But one of the things that is not taken care for you automatically, historically, is verifying that those VMs are up and running, but more importantly, the underlying application. And so what does that mean for somebody that works in operations? Well, you get paged in the middle of the night, got to go take a look at the vSphere UI and figure out which of those VMs got restarted, maybe cross-check that with like a CMDB and understand who are the owners and basically send them an email or even page them a call. All of that can be highly automated and automatically remediated through this workflow. We can take a look at the vSphere HA events, understand all the VMs are restarted, and craft a very simple function that will basically send an email, and it might even query your CMDB to understand the report. So now you have something that's built automatically. What about cases for storage filling up or VMs running out of storage, right? You can actually have automated workflows, especially if you have an existing runbook, to create these workflows to add additional storage or clean up the file system, for example, right? So quite popular around the monitoring aspect of it. Now, security is certainly a big key for many customers, especially when you want to make sure that you're able to identify, potential attacks, right? If you look at vCenter today for a failed login, it's quite interesting because the event itself contains the source IP of the client that's trying to perform the login. So this can become really, really useful information, and you probably want to know almost immediately. Today, when you look at the various events that's in vCenter, it can be quite daunting, and you have to have a very large database to keep all the information. And oftentimes, 80 to 90% of that information is not what you want, right? You only really want a subset. And using VEBA, we can selectively pick out these audit events, right? And send them through either a notification, right? Maybe it's Slack, maybe it's SMS, but we can also send this to other systems in a multiplex way. So not only can the cloud VI admins get these notifications when a failed login occurs, I can also send this to my security team who may want to archive this for longer duration, like a third-party data warehouse or for analytics purposes. Speaking of analytics, we see a lot of customers, look at these different events and start to do proactive things like it. Are certain types of workloads getting provisioned? Can I optimize my auditing workflows? I can take some of this information and apply machine learning to better understand, what are some of the workloads that need proactive provisioning, especially in the VDI world, right? So this is quite interesting. Again, similar to auditing, I can selectively pick those events out and actually place them into an external third-party source. And the nice thing about many of these solutions is that the consumption of these events, I don't actually need direct access to vCenter servers. So not only is this a very secure and also scalable solution, it allows me to get the information that's needed so that other teams can do their jobs, whether it's auditing, security, or automation purposes. So who are some of the personas that's targeting for VEBA? Well, certainly we want to make sure that we can help our VI and cloud admins scale out, right? Not worry about how to use our VMware APIs, but more about the business logic, right? Of what do you want to do with these events, right? Whether you're getting a Slack notification or you're automatically creating a ServiceNow ticket, for example. As I mentioned earlier, SRE and operation, quite popular amongst that folks, especially around the remediation sets of use cases. We have a lot of customers who have dedicated automation team, right? They're there to basically write all this automation from a function building standpoint, and then they make that consumable to the broader organization, especially to the VI admins and even SRE. We see a lot of potential opportunity as it pertains to the VMware third-party ecosystem. Just imagine a backup vendor. Instead of you having to create all these backup policies for every time a VM gets created, the third party can now hook into the lifecycle management of a VM. As a VM gets created, it automatically associates a backup policy and automatically applies that for your VMs, and so you're automatically protected. Same for security and network policies, right? So a lot of potential for VMware third party, and we start to see a lot of folks starting to take advantage of that. Okay, let me hand it over to Michael to take you through how some of our customers are taking advantage of VEBA.
Hey, thank you, William. Yeah, one of the great things of VEBA is actually the community that formed around this project in a very short time. And so we're lucky to have Scott Rosenberg. He's a practice leader at TerraSky, one of the partners of VMware, and he's been involved in the VEBA project like literally from day zero. And so we asked Scott if he could provide some feedback of how he's using and benefiting from VEBA and what really makes VEBA valuable to him. So he said, VEBA has allowed us to spend our time on what really matters and not on repetitive tasks. Getting started with VEBA is really easy, and adds huge value to almost every environment. So this is, I think, a great testament to the work William especially has done on building the appliance to get you easily started. But also Scott was heavily involved in providing feedback and improving the appliance and providing functions, examples, documentation, and so on. So thanks again, Scott, for your great work here. Scott also shared use cases, how he's using VEBA in production at his company. And so here's a compiled list of some of the main use cases he's built functions on VEBA to simplify his daily job. So first of all, one of the key use cases he has is creating DRS anti-affinity rules for TKGM clusters. TKGM is a VMware Kubernetes distribution. And so in this case, to make sure that the actual VMs that the cluster, the Kubernetes cluster is made of, are evenly spread and distributed from a DRS perspective, Scott uses VEBA and events to trigger DRS rule generation based on new events that are, for example, created, or when VMs move through the cluster and are like in an imbalanced state from an availability perspective. Another one is tag management. So whenever new VMs or hosts or data stores are created or changed, Scott is using VEBA to assign tags to these objects to then do further processing and filtering and management. This is really a nice one that I like. He's also using VEBA to shut down lab VMs over the weekend. So in VEBA, you can set up like cron jobs, which fire, in this case, over the weekend, and trigger a function, and then to power off a virtual machine or a couple of virtual machines. Next one, the canonical one, is Slack notifications when issues arise. William already spent a lot of time describing a notification use case here, but this is literally the canonical example to send enough notifications on issues. Host remediation is another one. So for example, Scott has seen hosts not really responding. And so he's triggering the IPMI interface to reboot the host if it's in a state where it's not responding based on the event there as well. DNS management and onboarding VMs to vRealize automation and generation of VRA object mappings are other examples that he provided with us. And they're all based on vSphere events. And we have more than 1,800 events in vSphere by default. So there's a lot of events that you can use to automate your own tasks. Thanks again, Scott, for your great work and providing this information to the community. So talking about these use cases, you might actually be thinking, oh, I have also this use case. So how can I get started? And in this presentation of VEBA, we actually want to make sure that we spend most of our time describing how you can get started. Not so much with the appliance deployment, because that's really easy and well documented, but also how you can write your first function. So in a nutshell, the anatomy of a VEBA function consists of 3 pieces, if you will. First one is the Dockerfile. Now, strictly speaking, you don't need a Dockerfile because what we use internally is an OCI compliant image. But most of our VEBA function examples use Docker and the Dockerfile to easily get you started. And we're assuming most of you will be familiar with Docker, or at least have heard about it. So the Dockerfile is used as the runtime contract, where you basically say everything that goes inside a container. And we've done a lot of work, especially around the PowerShell Power CLI functionality in VEBA, that you don't really have to spend much time on writing these Docker files and building all the lower level primitives. Next one is likely you will have configuration or credentials that you want to attach to your function, say, for example, tokens or vSphere authentication data. And this is done in VEBA through secrets. And secrets internally are actually Kubernetes secrets that we store in the Kubernetes appliance inside VEBA that you can reference and share between functions if needed. And last one, and most importantly, obviously, is the handler, which we call the handler, which contains your business logic. This is the place where you place your code and where you get all the goodies of VEBA that provides you with the events and information, what really has happened. So no need to talk to the vSphere APIs or fiddle around with putting up an HTTP server, which is usually required in that case. This is all abstracted for you. And William has done a great job and prepared a demo for you. And so we'll give you a little bit more detail based on the following example. So say we have a virtual machine that is powered on, but is not supposed to be powered off. And in that case, if it's powered off either by an administrator or because there's a shutdown or another event, we want to get notified. So whenever this happened, that the VM is powered off, we get an actual vSphere event here. And what we want is to trigger a PowerShell function. VEBA internally uses Knative as the backing implementation there, but this is just an implementation detail here. So we want to trigger a PowerShell function, which then sends information to Slack, for example, when this virtual machine was affected. So this is the high-level flow, and William is going to take you through the actual process of creating this function as part of his demo. Stage is yours.
Cool. Thanks, Michael. Okay, so let's take a look at how this actually works, right? In this environment, I've got this VM. It's called VMworld 2021, and it's already powered on. And one of the first things we want to do is we want to understand how do we actually retrieve that particular event. Well, as part of the appliance deployment of VEBA, we have something called sock guy. And think of this as basically a events viewer for the the appliance. And right, one of the first questions we normally get is like, well, how do I get the event itself? And more importantly, what's inside of the event, right? Basically the payload and the information. Well, this is a very easy way for you to basically retrieve that by mimicking it or basically performing the operation. So first step is to basically take a look at the powered off event. So I'm going to actually go and power it off. And what we're going to do after this in a second, let's get this to play. We're going to go back to our sockeye event. And if you look at the URL, it's really just the VEBA appliance /events. But you can see that these are all the events that are going through VEBA. And automatically, we can see that after I perform that operation, we found our powered off event, right? It's literally that easy. And here we can see information like the ID that was generated, which source it's from. So this will tell you which vCenter server. I've identified the event that's been powered off. And then we also have the payload here, right? This is what we're going to use to start writing our function. And at this point, you really don't need a vSphere environment or even a VEBA environment anymore. This can all be done locally, right? Just by simply copying this payload. So now I've cloned the repo. We have a Slack repo that we've cloned, and you can use any of the examples as starting baseline. And one of the really nice things that we've set up is that you can take this cloud event, right, which is that payload that you saw earlier, and copy this into a test directory. And we have this file called testpayload.json. This is the event that you're interested in. So whether this is a powered off event, whether it's a vMotion event, a vSphere HA event, right? You'll copy that information, and now you have the data mimicking an actual cloud event. And then we have two additional test scripts here, a shell script or PowerShell script. And this will basically help construct a valid cloud event. And so you want to update a couple of these fields. Most importantly, for vSphere-based events, you want to update the subject field, right? And this basically will tell this local service that, hey, I've received this event called powered off, and I want to do something with it specifically. So this allows you to do full development locally within your desktop without needing a VEBA appliance deployed or even a real vSphere environment deployed. And then once we've updated this small variable, you can see that we then send this request to localhost. And what you'll see is that we're going to basically build our Docker container, and that's going to run our function, right? And depending on what it's going to do as we send this event, it should go and do some action, right? Whether it's just printing to the screen or something more interesting like sending to Slack. Okay, so now the meat of the function is really this handler that Michael had mentioned earlier. And this has basically three parts to it, if you're looking at the PowerShell or PowerCLI module. The first is around something called process init. This is useful if you're logging into, like, say, PowerCLI, for example, right? Historically, if you want to do some operation, you have to log in, right? Which takes some amount of time, right, to initialize and make the connection and then perform the operation. Now, if you think about an event-driven system, if I'm getting events that come in at any arbitrary time, and every single event that comes in, I need to log in, perform the operation, and log out. That's not really efficient, right? We start to potentially build up a huge queue, and it could take some time. And so the nice thing that we built into the PowerShell and PowerCLI function is this concept of an init and a shutdown. And what it allows us to do is basically pre-connect to an environment, right? That means the connection is already connected and it's holding the server connection for you. So that way, when an event comes in, we automatically can perform the operation, like apply a vSphere tag, for example. The bulk of the code is going to be written in something called a process handler, right? In this case, we have our cloud event that comes in from VEBA, or in this case, from our local development environment, right? So if you recall earlier, we had that test payload.json file that contains our artificial event, right? We took it from a real environment, put it into a file, and when we execute that, this function is going to receive that information. And now you're starting to process that event. So the first thing that we're going to do is we're going to decode that event, right? It's most likely going to be in a JSON format. And we have something called an outer envelope of information, right? So things like the source of the event itself. And then we have data, right? So that's basically that JSON that we had just copied earlier. Here we're processing, since we're doing a Slack example, we're going to take that Slack variable and actually decode that. We'll come back to the secret in a second, but just know that if you needed to process secrets, we have the ability to create that and then basically inject that into the function. Now you can actually securely consume things. And so if you're sending us a Slack message, you probably need a webhook URL. If you're logging into vCenter, you probably have credentials for that example, and we can do this in a secure manner. The next set of lines that we're taking a look at is like for debugging purposes, right? And so dynamically I can enable debugging, whether I want to take a look at the information that's passed in or maybe the payload itself, and we'll see that in a second. And then after that, we're actually constructing the actual payload for Slack, right? So here we're just creating a standard PowerShell object that has the format of the Slack message that I'm interested in. In this case, I want to get the name of the VM, the user who powered off the VM, and then obviously the date and time on when this particular operation happened, right? And at this point, you're no longer working with vSphere API code. You're working on the business logic of what you're trying to do, which is, what do I want the Slack message to look like, right? We then convert this object type into a JSON, into a body payload. Again, we have some additional debugging. And then lastly, we're sending an invoke request. And here we're taking that payload, and again, we're processing that JSON secret. So you can see here, I only have a single secret, and there's a variable called Slack_webhook URL. This is that customized input that's going to be provided by end users, right? Which will be unique for every customer for each deployment. Speaking of which, we took a look at the JSON secret. We can see that we have this JSON file here. Now, this is something that you as a function author describes, right? This could be in any format. I just happen to write it in JSON because it's easier to process, especially if you have multiple entries. But this could be simply a flat file. It can be a CSV file. It can even be a YAML file, right? So you get to describe what you want this to look like. And then ultimately, as a function author, you're responsible for basically decoding this information and using it, right? So in this example, I just have a single variable called Slack_webhook URL, and that's retrieved. Now, for local testing purposes, like I mentioned earlier, not only can we capture the cloud event, right, and test that locally, we also want to mimic any kind of secret. So we do this by updating a file under the test directory called this Docker test environmental variable. The idea here is that we don't want to put secrets on the command line, especially if you're on a shared system or if you're doing demos, for example, right? And so I've created this file here that basically sets up the variable, and the outer variable is basically the environmental variable that will get projected into your environment, into your function, for example. And then depending on the number of variables that you want to define, these are just basically comma separated, right? So in this case, I just have my Slack webhook, and you can see the webhook URL there. And I just go ahead and save this file. Okay, so now the next step is we're gonna build our container, right? So you can take a look at the README for instructions, and then we're gonna go ahead and run the actual container process here, actually. Oh, sorry. So here we're gonna build the container. So we're gonna go ahead and change into that directory, and once we built the container, we're going to go ahead and run this, run the actual container image, passing it the environmental variable, and this basically runs our function locally on our desktop. So let's take a look at that in action. So we can see our files, and then before we can build it, let's quickly take a look at our Docker file, right? As Michael mentioned earlier, this basically talks about the contents of the image that we're going to build. And you can see it from the first line, this basically references the base image. We've already done work to build a optimized PowerShell base image, right? And this is officially built by VMware. So you can certainly use that. Now you can always build it yourself. We do have the raw source code for those other images if you're interested in it. But it's been optimized, so we have a base image for just the core PowerShell runtime. And we also have a base image for the PowerCLI runtime, right? So if you happen to want to use either of those images, you go and specify that, and that's where most of the examples are built off of. The second line basically takes your handler file, right? The thing that we just covered, and that's all of your business logic, right? That is what's doing the actual action itself when a particular event happens. And then lastly, the last line is basically running the server code, right? Which is responsible for setting up the HTTP handler. And as the event comes in, it'll automatically run the handler code. So pretty straightforward. You really don't need to know a lot about this, as Michael kind of mentioned earlier. But you can certainly add additional dependencies. For example, if you're using PowerCLI, you want to add additional PowerCLI modules, you can certainly do that in the Docker file. So now we're going to go ahead and build the file. So we'll go and do the Docker build, and then give it a name. So in this case, I'm going to call it lambw/VMworld 2021. You can certainly push this up to Docker Hub or even to your own private registry, but for local purposes, you only need to build it on your local system, and then you can run this locally. So now that we've got the image built out, we're now going to go ahead and run the container locally. So here I'm running the function. I'm passing in a couple of environmental variables like the port 8080, I'm also going to enable debugging. So in my code itself, I can actually have access to this environmental variable called function_debug, and I can dynamically test my code, right? And in production, I probably don't need to turn on debugging, so I can flip that flag as false. And then we're now specifying the container image that we had just built. So you can see that it's fully started and it's now ready and listening, right? And you can see these print statements in the actual handler itself. So now we're going to change into the test directory and we're going to go ahead and run that shell script. And remember earlier, we took that cloud event, right? And it's now sending information. So this is the exact same event that we have received earlier using the sockeye events viewer, but we're now able to basically manifest that locally. So we can see that the event has been successfully sent to our function. Our function is now processing the event itself. And we can see that it's already successfully sent the Slack webhook. So let's open up Slack and let's take a look to see if it actually did what we were expecting. And there you go. We've now manually tested our function locally without a real vSphere environment, without having to deploy the VEBA appliance. So at this point, we're ready to push our image up into registry. Here I'm using Docker, but you can certainly point this to any container registry, especially for if you're running within your on-premises environment. So now finally, what we're going to do is we're now going to deploy our function. So I've cleared our Slack message. You can see my VMworld channel is completely clear. There's nothing there. I'm going to go to my vSphere UI, and I'm going to head over to our VEBA vSphere UI plugin. This is a net new capability that got added in our 06 release. And one of the first things we're going to do is basically construct a secret. So rather than having to do this CLI, I give it a name, and then I give it the environmental variable that will be processing, as I mentioned earlier. And then we give it the actual webhook data. You might recall this looks very similar to the variables that we defined early, and that's by design, right? Is that we can mimic all of this stuff from a local development standpoint, making this easy to test without a real environment. Once you're done testing, we can then take the exact same setup and create the secret, right? And so through using the VEBA plugin, very, very simple, and this is nice because we can reuse those events. Next, we're going to search for our powered off event, right? So we can quickly filter that event over 1,800 plus events, and we go ahead and click on deploy. We give it a name for the function, and then obviously we provided the name of the Docker image that we built that is accessible by the VEBA appliance. This happens to be on Docker Hub. We're going to go ahead and leave the concurrency settings. If we have any additional environmental variables, we can actually set that up in the function. It makes it really easy to set up. And then here we can see our secret, right? And so if I have additional secrets, I can actually manifest that and use them in a function, or I can also share the secret. So imagine I have different functions that may have requirements for Slack. I can now reuse these secrets in a very easy manner. Review the summary, and we go ahead and click on finish. We can see that the status is currently unknown as it's going through the deployment. If we click on the functions tab and we refresh in a second, we can see that everything is now ready. So now we've successfully built our function locally, tested it. Now we've actually deployed our function into our VEBA instance. And for this particular function, it's going to react to the powered off event, right? And if I wanted to, I can actually select this function deployment and add additional events. Imagine if I wanted to send a notification when the VM gets powered on as well as off. I can easily do that in just a couple of clicks. But in this example here, we're just going to do the powered off event. So let's now take a look at our Slack example. Again, nothing is running right now as we expect. So let's go and power off our VM and let's see what happens now. Now, this is a real environment, right? And so what we expect is that when that VM gets powered off, hopefully it'll trigger the event. So VM has been powered off. Let's click over our Slack. And there we go. VM has been powered off. We see this is now live data coming from my vSphere environment. I can see that, hey, this was done by the administrator. I can see the name of the VM and also date and time, right? So hopefully this gave you a good example of just how to easily get started. And we have many, many more examples in there that you can take a look, especially for popular languages like PowerShell, Python, or even Go, for example.
Cool, thanks, William. What I really like with VEBA, and you've shown this like in 7 minutes, so under 10 minutes, with a lot of explanation. So probably like if you've done this before, you can do this in 3 or 4 minutes. What I really like is that in the handler code, there was nothing about vSphere, right? There was no vSphere code, no connecting to the vSphere event stream. You didn't have to worry about where to deploy the stuff, how to run it like securely, but also making sure that the function is available and scales and so on. This is all taken care of, all the boilerplate, all the noise. And so you can really focus on just writing your business logic and having a good day. So let's talk about what's new in the 07 release. So we always think that next release, there's probably not too much stuff that we can pack in, and then we end up with a huge list of stuff. So we compiled kind of our highlights of the V07 release, and we'll go through this briefly here. So first, and kudos to Robert, another contributor to VEBA, he added capabilities around monitoring. And so he created he added the C-Advisor plugin, which is a resource monitor where you can get information around memory, CPU, and other container metrics of the appliance. And just simply by browsing to the VEBA fqdn/top. So this comes by default with the 07 release, and you get some more data around usage of the appliance. Next one, also Robert again, so thumbs up, great work, Robert. He added syslog support. So you can specify a remote syslog server where the logs from VEBA, including from the functions, are being sent to. So you can, for example, send them to Log Insight to further process them or store them or do troubleshooting if needed. Then we've added webhook support. If you're not familiar with what a webhook is, basically it is an HTTP server that listens for incoming data. And in this case, VEBA spins up an HTTP server and it listens for incoming cloud events. Now, why is this useful? Well, we've got a couple of systems and even systems that we don't know about that are capable of sending HTTP data or cloud events, because cloud events is an HTTP compliant standard that you can send from, for example, from VMC Cloud Notification Gateway, Realize Log Insight, Realize Operations, AWS Event Bridge, or any other source, and send or ingest events into VEBA for adapters that we have not written or processors that we don't have written in VEBA yet. So this is really neat, especially around the extensibility story of VEBA. So you can add any cloud event provider, basically, that can send HTTP cloud events to VEBA. And last but not least, maybe the biggest highlight or news there was also with a lot of great contributions from our VEBA community is the new Horizon provider that we added. So we have a new setting in the configuration through the appliance deployment where you can specify a Horizon server where VEBA will connect to the Horizon server and retrieve up to the 850 plus events from Horizon that you can also ingest into VEBA. So even though we've talked a lot about vSphere in this presentation, we've added a lot of new providers and capabilities with webhook and Horizon here in this case, so that your function code can work against any other or any provided event source, not just vSphere. So this is really a goal that we've been following here, and we are glad to have Horizon support landing in the 07 release. Cool. And I think William has prepared another demo here as well.
Yeah, and I really like the fact that you kind of highlighted that, it's not just about vSphere automation. And again, that's really where we initially thought about from a project point of view, right? But then we quickly saw feedback from the community that started to expand upon other solutions, Horizon certainly being one of them, but we also have many other solutions that can now be integrated into VEBA with very little code changes. So imagine if you wrote a function that's using Slack, you can now bring events in from other systems like Log Intelligence, AWS, or even VMware Cloud, for example. And now you can actually get the benefit of additional event driven, and you get additional events that come into the system. So now VEBA is actually aware of more things than it was initially built for. So a really powerful capability and something that we expect to hopefully expand in the future as well. So let's take a look at what Horizon looks like. Like Michael mentioned earlier, Horizon has over 850 different types of events, really, really useful. And something we've heard from a lot of customers is sort of like, hey, can we get a Horizon provider? And so the last couple of months, we've been kind of going down this path and kind of exploring this technology. And in the latest Horizon 2106 release, they introduced a net new events API. That really has been the genesis for this to be successful, because prior to that, there really wasn't an official Horizon API that would allow us to basically build a provider. And today we have an official VEBA provider for Horizon. And in this demo, what I'll show you is basically a failed login to the admin console, right? This is something that you probably want to have fully secure. There probably shouldn't be that many folks having access to it, but for whatever reason, if somebody happens to log in incorrectly, you might want to know about it immediately, especially since the Horizon admin interface doesn't have things like two-factor authentication, right? So it might be something that you want to be cautious around. And so in this example here, we're going to go ahead and put in a bad actor, right? And once that authorization fails, we want to basically get notified immediately on, who is trying to log into the infrastructure. In this example, it's going to go to a Slack example, right? So Horizon's processing that information and checks that it is incorrect. And you can see immediately we get the Horizon event, right? Almost near real time. We see that it comes from a particular Horizon server. We get the message around who tried to log in and the exact time. So let's now log in as an actual admin and let's take a look at this information. Well, we can see here, there's also this events viewer in Horizon. This is the exact same set of events, but rather than having to manually log in and do this filtering, we can actually now react to any one of these 850 plus events and start to do some really interesting use cases. And you can see here, leveraging our sockeye interface, we can actually get those events in real time. So as you're thinking about, which Horizon events you want to create functions for, I can actually quickly see that information as shown in the demo there, right? So just a quick sneak peek at what you can do with Horizon, and certainly there are several other VMworld sessions that will be covering Horizon in much greater depth from a VEBA point of view. So definitely exciting to see what our customers are going to do with that. Okay, so switching gears a little bit, talk a little bit about commercial offering support. One of the things that we heard loud and clear from our customers is sort of like, hey, is this something that VMware is thinking about as a product, delivering to customers as well from a support standpoint? It definitely makes a lot of sense, right? Especially the value that it shows immediately, especially for some of our enterprise customers. Today it is still Fling, completely open source, and we continue to support the community in that standpoint. But we certainly understand from a customer point of view, they are looking for an enterprise offering as well as support if something does go wrong or if they have some questions. So we're really excited to share some updates with you on that front. So before we get into that, I definitely want to switch gears slightly and introduce something that we announced earlier this year called the Cloud Native Runtime for VMware Tanzu, or CNR. This is our commercial offering of Knative. And if you recall earlier, Michael mentioned something about Knative, right? This is basically our backend infrastructure that provides not only the serving, but also eventing component that VEBA is built on top of, right? So it gives you an easy way to build serverless runtime, both for application serving, right? If you're just writing basic services, really easy and abstracts away the complexity of Kubernetes and makes it very easy for developers to build application. But it can also use for eventing and functional programming on top of Kubernetes, again, taking advantage of the Kubernetes API and simplifying that, right? And that's really what VEBA has built on top of this infrastructure. And as part of CNR, there's two components that I kind of mentioned earlier. There's a serving aspect and there's an eventing. I'll come back to this in a second. It is also highly optimized for various other Tanzu integration, whether that's Tanzu observability, Tanzu build services, and even for other workflows. So out of the box, we can easily integrate with some of these services, right? So not only can you go from source code, but will allow you to quickly build these images, secure them, and also observe them for telemetry and optimization purposes. CNR can run on any conformant Kubernetes infrastructure. So obviously we can run this on VMware TKG, but we can also run CNR on any of the public clouds that have a conformant Kubernetes cluster. And then from a deployment model point of view, you can download this not only from TanzuNet, if you're familiar with that, or you can actually deploy this through Tanzu Mission Control, which is our SaaS offering for you to manage multiple Kubernetes infrastructure, whether that's on-prem or in the public cloud. So just a little bit of information about CNR. Again, like I mentioned, this has officially GA'd earlier this year. And as part of CNR, like I said, there's two components to it. There's a serving and there's an eventing. Today, eventing is still currently in beta. But one of the really cool things that eventing comes with are a number of these things called sources. One of the sources is something called Trigger Mesh sources for AWS. Trigger Mesh is an organization that we partner up with. And so if you want to do any type of event-driven automation based on AWS events, so for example, if an S3 bucket's created, maybe I have a backup that's running, I can actually trigger off that information, right? And this event for sources allows me to basically capture those events and write a function that reacts to that, right? And this is just one of the core sources that's available. Another interesting one that's also available as part of the eventing framework is a sources or vSphere. And that's actually quite interesting from a VEBA point of view because what we've been doing for the past several months is actually taking the logic, the heart of VEBA, which is really this VMware Event Router, and actually been porting that functionality into source of Visa. Really kudos to Michael and the time and effort that he spent doing this work and doing this in an open source manner, right? So not only is the Knative app infrastructure completely open source, which is what CNR is built on top of, but also all of these sources are publicly available. And so what we wanted to do was basically take VEBA and the event router, port that information into source of vSphere. So now that you have the ability to derive your own VEBA implementation using CNR, right? And so really going from open source to our commercial offering, this is how we want to take this to market, right? And doing so that you can see how this works in a open source manner. And so as you build these functions, you're more comfortable with it, that you can easily implement this. And then from a supportability standpoint, CNR will be available through multiple channels. First is through Tanzu Advanced. This is a SKU of Tanzu offering. There are a number of functionalities in there, including a Kubernetes runtime, support for things like Tanzu build services and other functionality, and CNR is under that SKU, right? So if you're interested for both getting a Kubernetes runtime and additional Tanzu support and functionality, Tanzu Advanced, we also recently announced Tanzu Application Platform. This is really designed and geared towards developers who wanted to basically build applications that's tailored to run on Kubernetes. And so for those types of use cases, CNR is also included in TAP. And so from a supportability standpoint, you can certainly look into either of these offerings that will support CNR. Now, I mentioned earlier, eventing is still currently in beta, and that is still accurate up to VMworld. We do expect this to hopefully go GA sometime in Q3 or end of Q3 for 2021. And so with that, we're really excited to share that, VEBA is productized as part of CNR. And hopefully this answers a lot of the questions that have been floating around the community around, is this something that VMware is taking to market? And obviously, can I get support from it? And the answer is yes and yes. So we certainly look forward to when eventing goes GA later this year. And we're certainly excited that VEBA has now been officially productized as part of CNR. And again, our commitment to open source still stands. Michael and I continue to work on efforts in open source, and a lot of that is really derived from feedback, community folks' feedback, like Scott and others in the community. So we certainly welcome more contributions, and hopefully you see a path forward for productization. And as we work on other providers, we definitely value your feedback, because that definitely has an influence on where this goes from a commercialization standpoint. So I'm going to pass it back to Michael to talk a little bit about some of the project features and take us in closing out the session.
Thanks, William. I think this is a great transition, actually talking about project features, because by now it should have become clear that VEBA is a community-driven project. And so William and I, we are committed to keeping the spirit of innovating in the open. So let's talk a little bit about things that we, first of all, heard from you that we should be improving or thinking about, and also things that we are actually planning to do in VEBA. And this is a list, not necessarily like by priority. This is merely a discussion point that you can provide feedback on where we should be focusing our time on. And at the end of this presentation, we'll share ways to contact and reach out to the VEBA community so you can start or contribute to these features and VEBA's future. So first of all, we are thinking to further simplify the way that you interface with VEBA. And when it comes to writing a function, even though we have addressed a lot of the concerns in the past with the vSphere UI plugin, and also with the PowerShell work that we've been doing to simplify the way to write PowerShell-based functions or PowerCLI-based functions, there's still a little bit of room for improvement here. And so we are thinking about a way to use the Knative client plugin, which is KN, to bootstrap an environment for you by, for example, saying kn func create. And there's already work in the Knative community to support Golang, Java, JavaScript, and so on. But we also want to make sure that PowerShell is a first-class citizen there. So there's literally work there that we have to do in order to make the bootstrapping process of writing a function much more smooth for you. Second, we want to hear from you. Do you need or do you want more event processors and event providers, or if you want event sources and event targets or destinations? And so even though we have Horizon and with webhooks, we kind of support already a majority of use cases and scenarios, there's probably here and there event providers and processors that you want to have support in VEBA for. And so we want to know from you, what is the priority here that we should be taking in supporting more processors and event providers. William already touched on this, that VEBA's kind of commercialization story is Cloud Native Runtime, the product from VMware. But there's still a little bit of work to do here to make the experience for you almost like transparent and equivalent. So for example, we want to make sure that if you write a function for VEBA and you deploy it to the Cloud Native Runtime in production, there shouldn't be any differences there. And right now, there's a little bit of difference when it comes to these cloud event attributes, for example, subject and type, that we over time will kind of smooth out. So you will see some changes in VEBA to adapt to Cloud Native Runtime to make the transition from this open source community-backed project to a commercialized project and product more easy for you. Next one, and we've heard a couple of questions in the Slack channel from community users around how resilient is VEBA? How does it scale? And what should I do in terms of availability of not only the functions, but also the platform itself? And so we are currently writing and updating our documentation to provide more information there, but there's also work that we need to do under the covers to improve the scaling and resiliency characteristics of the internal messaging system that we are using, which is currently RabbitMQ. There's a bit of work that William has to do on internal refactoring, like updating versions that we use on Knative and Kubernetes and so on. So there's a lot of housekeeping that we need to do in order to be up to date with the releases and also not risking to become like or using deprecated projects in our appliance. And speaking of deprecation, we're actually, or like in the 07 release, we have deprecated support for EventBridge and OpenFast as a way during the appliance deployment. That doesn't mean that they are going away as processors in the event router, which is the core of VEBA right now, but we are thinking about also deprecating them in the logic itself in the event router. This is merely because we haven't seen much usage of this. And we basically also have to maintain this code and make sure that like from every release, it's still usable and so on. So this kind of puts a little of work on our end that we have to do on maintenance, which we can't spend on innovating on the platform. So we are actually thinking about deprecating some processors there and would love to.
The thing to also bring up there on the deprecation is that if you look at like the EventBridge, we definitely see a lot of valuable use cases that come on EventBridge, and with the trigger mesh for sources for CNR, we're able to actually get that functionality. So as we unify bringing VEBA to CNR over time, we're also going to be taking advantage of what's coming out of the CNR platform and some of these sources and their providers, right? And so now you can actually deliver EventBridge through these existing sources. And obviously Knative is going to be our preferred backend implementation. And so part of the deprecation is really not only to simplify our life so that we can really focus on net new innovations, right? But some of this functionality is actually available in these existing implementations that we'll be taking advantage of.
True, good point, William. And last but not least, we heard users who've been using VEBA for a couple of releases now, asking for a better way in order to deploy multiple appliances, for example, but also lifecycle management, like updating or doing new version release upgrades and so on. And so we have some ideas around that. It's not an easy undertaking, but as we see VEBA also evolving as a platform where not only the eventing system is maybe shipped on, but maybe also other flings from VMware, we need to think about better lifecycle management around VEBA to make your experience easier as well. All right, what's the call to action? This is where you come into the picture, right? So first of all, we want you to try out VEBA if you haven't already done so. And we want you to provide feedback. Does it work for you? What are you missing? Which value does it provide to you? Because we take your feedback seriously. And then we work closely with the VMware product engineering teams across our different business units to make sure that, first of all, we get proper and mature eventing support across our products, but also that VEBA itself is a sustainable business when it comes to, for example, the cloud native runtime as a commercialization, sorry, heavy, bad word, and productization story there. Then obviously VEBA is there to solve your business problems. We don't want you to use VEBA just for the sake of using VEBA. We want to make your lives easier. And I think you've seen that during William's demo around writing a function. It's literally that easy to get you started there. And so we want actually to simplify your life. That's the main goal that drives our intentions behind VEBA. And then last but not least, we have seen a lot of users who have started using VEBA that they also started contributing, for example, examples. Function examples or documentation or clarifying some things that weren't clear or scalability things, etc. So this is always a great way to provide feedback. And as you know, this is not only touching VEBA, but also the products behind VEBA. So how can you reach out? There's multiple ways. We have a web page. You can reach out on Twitter. We have an email distribution list, dl-veba@vmware.com. And then there's our public VMware Code Slack channel where we have a dedicated VEBA channel where you can get support, not only from William and myself, but also the VEBA community is there and a lot of end users as well. So you'll certainly get help there as well.
Yeah, and it's a great way to actually interact with different, folks within the community. If you have a use case out, in fact, a lot of the function examples started in that Slack channel. And I think to date, we're over 200 plus folks now, which is pretty insane when we first started from, right? And so, if you got an idea, you don't know how to solve it, or you want to see what others are doing, come join the Slack channel. It's great. Everybody's super friendly. And in fact, we've had a number of contributions that stem from, one user writing some code and they've been building on top of them. And that's really the benefit of not only open source, but certainly the VMware community that we see all the time, right? So definitely check it out.
Cool. Thanks, William. With that, we've reached the end of the presentation. We hope you liked it. Please provide the feedback and reach out to the VEBA community, and would love to hear your feedback. See you there. Bye-bye.
Thank you. Bye-bye.